Pictured here are some exponential growth graphs. They are growth graphs because the factor here, b, is greater than 1. On all exponential function graphs, the y-intercept represents the a value. The, 0, a is the y-intercept, so it's where it crosses the y-axis. That tells me that this graph will have a start value of 2, and it does. This will have an a value or a start value of 3, and it does. So comparing these two graphs, I could identify which one was 2 times 2 to the x and which one was 3 times 2 to the x by looking at the start value. When the growth factor, b, is bigger, the graph gets steeper. So if I were asked which one of these was 2 times 3 to the x, which was 2 times 5 to the x, I wouldn't need to figure out what the exact values of particular points were. I would just notice that this b value, 5, is bigger than 3, so that means I'm looking for a steeper graph. Notice that there are arrows both here and here. The domain of all exponential function graphs is all real numbers, but the range is going to be y is greater than or equal to 0 in this case. The graph gets infinitely close to the x-axis, but never touches it. We say there's an asymptote on the x-axis at y equals 0. Matching these rules up, I am first going to look, let's see, this looks like it has a y-intercept of 3, so I have options of y-intercepts of 3 and 4. This looks like a 3 as compared to these, which are closer to that 5. So I can right away say that j of x and L of x go with the first two graphs, whereas k of x and m of x with a start value of 4 go with these two graphs. Now I need to compare steepness. So the second graph up here is steeper than the first graph. That tells me that when I'm picking between 3 times 10 to the x and 3 times 3 to the x, this one is going to be j of x. Because I have a steeper graph, that means I have a larger b. This one's going to be L of x, less steep, so that will be a smaller growth factor. Same idea here. We both have a start value of 4, so that will be a 4 for the a. 2 to the x versus 12 to the x, m of x will be steeper than k of x. That allows me to identify that the left graph in the bottom row is m of x, the right graph is k of x.